I'll talk about how the sigmoid function naturally arises from the exponential family of distributions when we're looking at the Bernoulli probability distribution. Recall that the Bernoulli function of your random variable x given your parameter mu is given by mu to the x times 1 minus mu to the 1 minus x. Recall that the Bernoulli probability function gives us the probability of getting a 1 or the probability of getting a 0 for a random variable x. So let's say that your parameter mu is 0.5, then we can calculate the probability of getting a 1 by plugging into the equation 0.5 to the 1 times 1 minus 0.5 to the 1 minus 1. This becomes 0.5 raised to the 0, which is equivalent to 1, and we get the final answer to be 0.5. So the probability of getting x is equal to 1 given your mu is 0.5 is 0.5. Now the Bernoulli probability function belongs to a family of probability functions called the exponential family. The exponential family of probability functions has this general form: p of x given some parameter, and this is called the natural parameter, is equal to h of x times g of your natural parameter times e of your natural parameter times n of x. And this is the general form, where h of x is some function of x, n of x is also some function of x, g of your natural parameter is some function of your natural parameter, and this is your natural parameter. Now our question is, how do you convert the Bernoulli form earlier of x given mu to this form, which is your probability of x given your natural parameter? Our Bernoulli function, let's say p of x given mu, has this form: mu to the x times 1 minus mu to the 1 minus x. Now recall this relationship, which is given some y, which is defined as the natural logarithm of x. It follows that e to the y is equal to x. So it follows that e to the ln of x is equal to x. This means that we can convert this into this form: p of x given mu is equal to e to the ln of mu to the x times 1 minus mu to the 1 minus x. We can rearrange this to be e to the ln of mu to the x plus ln of 1 minus mu to the 1 minus x. We can evaluate this further into e to the x ln of mu plus 1 minus x times ln of 1 minus mu. And then if we focus on this part, this is equivalent to ln of 1 minus mu minus x ln of 1 minus mu. And then rearranging the terms, we get e to the x ln of mu minus x ln of 1 minus mu plus ln of 1 minus mu. And this is equivalent to e to the x times ln of mu minus ln of 1 minus mu times e to the ln of 1 minus mu. Then recall that e to the ln of x is equal to x. So this follows that e to the ln of 1 minus mu is equal to 1 minus mu. And then we can simplify this to e to the x times ln of mu over 1 minus mu. So finally, we get the form p of x given mu is equal to 1 minus mu, which comes from here, times e to the ln of mu over 1 minus mu times x. And we just rearrange these terms here. We can now compare this with the general form of the exponential family of distributions, which is p of x given your natural parameter is equal to h of x, g of natural parameter, e to the natural parameter times n of x. We can now form a one-to-one correspondence between the Bernoulli equation and the general form, and we can see that x is equal to n of x. This is equal to the natural parameter. H of x is equal to 1, and 1 minus mu is equal to g of your natural parameter. Summarizing the mappings, we get n of x is equal to x, natural parameter is equal to ln mu over 1 minus mu, g of natural parameter is equal to 1 minus mu, and finally h of x is just equal to 1. Now using this relationship, let us evaluate mu as a function of your natural parameter. given this relationship, we can see that e to the natural parameter is equal to mu over 1 minus mu. Then solving this using algebra, we can get e to the natural parameter minus mu e to the natural parameter equals mu. So e to the natural parameter equals mu plus mu e to the natural parameter is equal to mu times 1 plus e to the natural parameter. So we can get mu is equal to e to the natural parameter over 1 plus e to the natural parameter. Then we can divide both sides and we get 1 over e to the natural parameter plus 1. So mu now becomes 1 over 1 plus e to the negative times natural parameter. And this is equivalent to sigma natural parameter. And this is called the logistic sigmoid function. So what we have shown is using the Bernoulli distribution of x given mu, we converted it to the standard form of p of x given a natural parameter, and then computing for mu, we get the logistic sigmoid function as a function of the natural parameter of 1 over 1 plus e to the negative of the natural parameter. Now let us complete the standard form of the Bernoulli equation going back to this. We have solved what mu is in terms of the natural parameter. So we can now calculate g of the natural parameter, which is 1 minus mu. So let's do that. G of the natural parameter is equal to 1 minus mu. And because we know that mu is equal to the sigmoid of the natural parameter, then g of the natural parameter is equal to 1 minus the sigmoid of the natural parameter, which is just equal to 1 minus 1 over 1 plus e to the negative of the natural parameter, which is equivalent to 1 plus e to the negative of the natural parameter over 1 plus e to the negative natural parameter. Then subtract 1 from the numerator. So we get e negative over 1 plus e to the negative n, and then divide the numerator and denominator by 1 over e to the negative n, such that what we get is 1 over e to the negative n plus 1, which is equivalent to 1 over e to the n plus 1, where n is your natural parameter, which is equivalent to the logistic sigmoid of negative of your natural parameter. And this is g of your natural parameter. We now have all the elements needed to complete the standard form of the Bernoulli function. Again, the standard form looks like p of x given your natural parameter is equal to h of x, g of n, e to the n times n of x. And we found that this is 1. This is the sigmoid of negative natural parameter, and this is equal to x. So this means that the final form is sigmoid of negative natural parameter e to the natural parameter times x.